Hi guys, welcome to the K-means clustering project overview lecture. In this lecture, we are going to explore another real dataset which provides measurements of the geometrical properties of kernels belonging to three different varieties of the wheat. A soft X-ray technique and grain package were used to construct all 7 real-valued attributes. Original dataset is available at UCI Machine Learning Repository, and you can download the file from that website. However, I recommend using the file which is seed_data.csv provided in the course material. The provided file is processed for the column names, separators which are somewhere longer than one character and also of different form. The data file contains following 7 features and 1 target class. So the features are area, perimeter, C is compactness, LK is the length of kernel, WK is the width of kernel, A coefficient is asymmetry coefficient, LKG length of kernel groove, and another one which is target class as target column 0, 1 and 2. Please note, this is unsupervised learning project. The target class is not available in such learning. You can ignore the target class or use it for just to recheck what the algorithm is clustering. This is practice exercise. Let's move on and see what he's asking for. In the first one, he's importing some required libraries, pandas, numpy, matplotlib, and so on. You just need to run this cell. Moving forward, please read the data file seed_data.csv and show the head of the file. Now I'm sure it's very simple for you guys to read the file and display the head of your dataset. The next one is how many entries we have in the dataset. Simply you need to call the info function here, and then moving forward display the basic statistics, mean, standard deviation, and so on. You need to call describe function here. Moving forward to the exploratory data analysis, he's asking for how the area A is related to the compactness. Create a scatter plot, please. Luckily, we have the target values. Pass it as hue argument, and he's asking for, do you have any comment on clusters? So you have to recreate this plot. Along x-axis we have A, which is area. Along y-axis we have C, which is compactness. And you see 3 clusters, so you need to pass in target as hue in your plot. So moving forward, let's see how area A is related to A underscore coefficient using scatter plot. Hint is again hue equal to target. So you need to recreate this plot, and A is along x-axis, which is area, and the coefficient A is along y-axis. Once again, you see 3 clusters. You need to pass in hue argument. Moving forward, recreate the plot below, a stacked histogram. If possible, please use SNS C-bonds facet grid. I hope you still remember what is facet grid. If you want, you can click this link that will take you to the C-bonds facet grid official documentation. So you need to recreate this plot. So moving forward to the k-mean clustering, import k-means from Scikit-learn and create an instance of k-means model with 3 clusters. 3 clusters because we know we have 3 target classes. So the next one is fit the model to all the data except the target. You can drop target column and fit the model on all other features. Moving forward, how to get the cluster center vectors, pass them to the centers and get the output. So you need to get this output. Simply get these cluster centers in centers and get the output. The next one is you have the fitted model. Get the labels for k-means and create a new column k-labels in your data frame. Check the head of your data frame now. If you still remember the previous lecture, you can call .labels underscore on your trained model k-means to get the labels for your dataset. And then you can add a new column, k labels, in your existing data frame. Notice now you have a target and k labels. Targets are the original labels, where k labels are the predicted one from your trained model. So the next one is recreate the plots below. So these are the similar plots that you created in the previous lecture. On the left, C parameter in scatter is the predicted cluster class, which is df k labels column, or k means dot labels underscore. The centroids on the k-mean plots for the selected features A and A coefficients are also shown. So these are the centroids for these three clusters, and the centroids you already have in centers. On the right, target is passed as C parameter to the scatter. So in this right plot, you have to pass in the target, which are the original labels for all the data. So moving forward to the elbow method, estimate the elbow point to see if our selection of k was right. So this is the same one what you did in the previous lecture. You can use for loop and range function for k from 1 to 10 and get a dictionary with k as keys and the squared of distances as value in that dictionary. Next one is generate the elbow plot given below. So once you have the dictionary with key value pair as k and the squared of the distances, you can simply use matplot plot function to get this plot. And you see somehow 3 is a good value for k. So guys, once again, I suggest you try to answer all these questions before you move on to the next part, which is the solution lecture. If you need any help, you can explore the previous lecture on k-means algorithm. I hope all the tasks will be very easy for you at this stage. So see you in the next lecture, where we are going to solve these tasks together. Good luck.